Alright, so for this week I just decided to do problem number 33 in section 10.1, which asks us to evaluate this piecewise function by first graphing it and then finding its Laplace transformation. So first let's start with the graph. Y-axis, x-axis, and I'm going to put the x-axis out to, let's say, 5. And then the y-axis we'll do 1, 2, 3. Awesome. Now, at t equals 0, t is 0 as stated by the piecewise function. At t equals 1, f of t is equal to 1. So, that point right there, and it is closed because of the less than or equal to sign. And there's the first portion of our piecewise function. And then from t is equal to 1 to t is equal to 3, f of t is simply equal to 1. And that right there would be an open point because both of these greater than or equal to, or excuse me, greater than or lesser than signs are without an equals to. There we go. T is equal to 1. And then from 3 up to infinity, f of t is modeled by e to the t minus 3 power, which would be an exponential function. So it would look something like that. So there we go. There's the graph of the piecewise function shown right here. Now in terms of finding its Laplace transformation, let's plug and chug. So the Laplace of f of t is equal to the integral from 0 to infinity of e to the negative st times f of t dt. Now, slight problem. F of t is not just one function for all real numbers. It's broken up into pieces. Now luckily we can break this integral into that. The problem is we end up with 3 different integrals. So the Laplace of f would equal to, see, the integral from 0 to 1 of e to the negative st times t dt plus the integral from 1 to 3 e to the negative st times 1 dt plus the integral from 3 to infinity of e to the negative st times e to the t minus 3 dt. Alright. This one's simple. It just ends up being e to the negative e to the negative st over s. As for this one, we've got to do a little bit of integration by parts. Which for that, if we let the u equal t and the dv equal e to the negative st, du is dt, v is negative e to the negative st over s. So for that first function, we end up with, let's see, negative t e to the negative st over s, and then it would be v du, so, and that's evaluated at 0, 1, plus the integral of e to the negative st over s dt, and that's also evaluated from 0 to 1. Now I took the negative out of this exponential and place it out here, so that would be plus. I'm going to erase this since it's not necessarily needed any longer. So then this integral comes down, we end up with, see, minus e to the negative st over s, evaluated at 1 to 3. And then I'm just going to bring this one down and combine the two exponents. Oops, that's not supposed to be a 0. E to the negative 3 times e to the 1 minus s t dt. Awesome. So, continue this on. We end up with negative e to the negative s over s, and when we plug in the 0 with that t there, it just ends up being 0, so that value is not needed, plus, let's see, 1 over s times negative e to the negative s t over s, evaluated at 0, 1, minus, let's see, if we plug a 3 in there, we end up with e to the negative 3s over s minus e to the negative s over s. And for this integral, we end up with plus e to the negative 3 times the integral from 3 to infinity of e to the 1 minus s t. Alright, bring that down a little bit. Let's see. Plug 1 into there. Negative e to the negative s over s plus 1 over s, because it would be a minus, given that it's an integral with bounds, and e to the 0 power was just 1. Minus e to the negative 3s minus e to the negative s over s plus e to the negative 3 times, let's see, that would be e to the 1 minus st over... I completely forgot one step. We can't take an integral with infinity as one of the bounds. So we would end up with e to the negative 3 times the limit as b approaches infinity of 3 to b e to the 1 minus s t dt. Plus 1 over s squared minus 1 e to the negative 3s minus e to the negative s over s plus e to the negative 3 times, the limit as b approaches infinity of e to the 1 minus st over 1 minus s, evaluated from 3 to b. Awesome, so negative e to the negative s. Actually, I'm going to combine these two fractions together. So negative s e to the negative s minus e to the negative s plus 1 over s squared minus... In fact, I'm actually going to combine all three of these fractions. So negative s e to the negative s over s squared plus minus e to the negative s plus 1 minus s times e to the negative 3s minus e to the negative s, and that is all over s squared. Awesome. So this ends up being e to the negative 3 times e to the 1 minus s b over 1 minus s minus e to the 1 minus s times 3 over 1 minus s. Alright. So negative s e to the negative s minus e to the negative s plus 1. And then if we distribute that s, this negative s e to the negative s cancels with this s e to the negative s, because when we subtract the multiplication, we end up with a positive. So those end up canceling. And we're left with negative e to the negative s plus 1 minus s e to the negative 3s over s squared. And I realize I forgot my limit over here. Awesome. E to the negative 3. Limit as b approaches infinity of e to the 1 minus sb minus e to the 1 minus s times 3 over 1 minus s. In fact, actually, I'm going to back that up. So I want to point something out. Negative 3, obviously, limit's necessary. If we keep these separate, what we end up with is e to the b over e to the sb 1 minus s, because of this exponent right here, minus e to the 1 minus s times 3 over 1 minus s. Now the good news is this value right here, or this term, is not affected by the limit because there's no b value in this term. And if we plug infinity in for this, right now it's rather inconclusive. However, e to the sb can be separated into e to the s times e to the b, at which point e to the b over e to the b can be brought out, and it just reduces to 1. So this whole limit ends up becoming inconsequential in the end for that infinity. So I'm going to erase some stuff up here so we can write out our answer. So bring it back up. Negative e to the negative s minus se to the negative 3s over s squared plus e to the negative 3 times 1 over e to the s times 1 minus s minus e to the 1 minus s times 3 over 1 minus s. Awesome. Now the only difficulty here is simplifying. So negative e to the negative s minus se to the negative 3s over s squared plus e to the negative 3. And I'm going to combine these two fractions by multiplying each of these by 1, essentially. Or at least this term right here. So we get 1 over e to the s, 1 minus s, minus e to the 1 minus s times 3 times e to the s. Awesome. Now, how does that... This is an interesting simplification. And in the interest of time, I'm not going to do it because that is far behind where we are. So, I'm just going to state the Laplace of f of t is equal to negative e to the negative s minus se to the negative 3s over s squared plus e to the negative 3 times the quantity 1 minus e to the 1 minus s times 3 times e to the s over e to the s times 1 minus s. That right there is the Laplace transform of this f of t function right there. Thank you.